in this example reaction, we're just going to say A plus B, maybe it makes 2C. And I found out the delta H for that reaction is known to be positive 50 kilojoules. All right, and then there's another reaction that says 2C plus D makes B plus E. And I found the delta H for that reaction, and it is 17 kilojoules per mole. Well, what Hess's law says is that if you take two reactions and you stack them up like this, we did something kind of like this with our electrons previously. We could like add up reactions and see what comes as we put everything on the right side on the arrow and everything on the left side of the arrow. We're going to do that. We're going to just drop everything down, but if something appears on the left and the right, we can cancel it, all right, for certain numbers of them. So like in this one, I would drop down A. I'm going to drop down B. I'm actually going to go ahead and cancel the 2C since it's on the left side of one equation and the right side of the other. They would end up canceling in the end if I brought them on down. Oh, actually something else cancels. I didn't notice. What other letter kind of cancels? B. I wish I'd seen that. B actually cancels as well. So I'll take it out of there. So it's just A plus D. And then all that's left on this side is E. If I wanted to know the delta H for this reaction, I just add up the delta H's of the two reactions that I added up. That's all there is to it. So what's 50 plus 17? What's that, Jordan? 67. 67 kilojoules. That is Hess's law, all right? The problems will sometimes be more challenging because you're not necessarily given the correct blue equations in the first place. Sometimes in order to get to that black equation, you might have to take one of the reactions that's originally given to you, and you might have to flip one of them. Maybe we wanted the black equation, and maybe we wanted E to be on the right, but they gave us E on the left. So we would have needed to flip the equation and change the maybe negative 17 to positive 17 or something like that. So it's a little bit like a puzzle as far as how do we get the blue equations set up in the first place. But once you get them set up, it's just as easy as adding up the delta H's. That's Hess's law right there. All right. Any questions on that before we do the specific examples? All right. So again, you can see what the question's gonna look like. I like kind of a series of steps to kind of like have some instructions as far as what I'm supposed to do. And so I've got this on your sheet here. So in general, the ones that are given to you with the delta H values, so like on this one, it's these three equations. I'm going to call these the menu, all right? So if you're going out to dinner and you've got a menu right here. This top one here, this is the target, all right? This is your total meal, what you exactly wanted to make overall for your dinner or whatever. So I call this the target reaction on top, the one you don't have a delta H for, and this is the menu. You can do things with the menu. You can flip these reactions. You can double these reactions or whatever you need to do in order to make them look like the target equation. So you got to get your reactants on the left side. So you look at the menu and you find out which one of those has reactant number 1. Do I need to flip it? Do I need to double it so the coefficient's right? You do that with all the reactants. If you flip a reaction, if you double a reaction, you need to adjust the delta H as necessary. Either change the sign or double the delta H or something like that. And then you do the same thing with your products. Multiplying the coefficients, adjusting the delta H if you have to, maybe changing the sign of it. And then finally, step 3 is what we just did with the two blue equations and making the black equation. We just added up the delta H's, and we got the final delta H. Now, occasionally, you're going to have a reactant or a product that's in the menu twice. Like oxygen often appears in the menu twice. You just skip over it and go on to the next substance in the target chemical reaction, as we'll see in some of these examples. All right, so this is the one, I think that's on this is at the bottom of the sheet. Let me go back to the one on the top of the sheet you had there. So this is the one we'll do first. It says find the delta H for the reaction. 2H2 plus 2 carbons, oxygen makes the C2H5. And then the whole point of this, again, just like the past two lessons, just different ways, how do you find the delta H of this reaction? So when you're given a series of reactions and their own delta H's, you're going to use Hess's law. So we're just going to take it one reactant at a time. Again, this is the one, I'm going to call this the target. So in my target reaction equation, I need two H2s. So I'm going to go to my menu. I'm going to call this, just so we can talk about it, I'm going to call this reaction 1, reaction 2, and reaction 3. Which one of those reactions has hydrogen as H2 in it? Number 3, right? It's on the left side, so that's good, but I need it to have a coefficient of the 2. I need it to have a coefficient of the 2. So what I'm going to do, I'm going to rewrite that equation, and I'm going to just double everything. I'm going to say 2 hydrogens plus 1 whole oxygen. I'm going to double all the coefficients. You can't just double one coefficient. You have to double them all. Otherwise, it won't be an equation anymore. It won't be equal. And so now my new delta H, I'll just go ahead and put it way over here. My new delta H is positive 285.8 kilojoules. I'm just going to separate my menu from my actual work. All right, so I took reaction 3, I doubled it. Did I double the delta H or did I forget to double the delta H? I just wasn't thinking. I'm not supposed to make it positive. I'm supposed to leave it negative, because did I flip the reaction around? No, I should have left it negative. But I should have doubled it. So let's go ahead. In your calculator, do 2 times negative 285.8. We get there. Get negative 571.6. That's what I'll actually end up putting there. All right, so you okay?
Yeah, this is the...
Yeah, go ahead. Yeah, whatever. All right, doubled the reaction, doubled the delta H. I should have left the sign alone because I didn't flip anything around. Next thing we got to look for is 2 carbons. All right, so now I'm going to look on my menu for carbon. Which equation involves carbon? Reaction number 2, huh? And I need 2 of them, so I gotta order 2 of them off of here. So I'm going to take that reaction number 2, and I'm going to double it as well. 2 carbons plus now 2 oxygens. I try to keep my arrow lined up best I can. Makes 2 CO2s. Now for my delta H for this one, I'm going to take the original one and I'm going to double it because I doubled everything. I'm going to leave the sign alone because I didn't flip anything. All right, so let's try that. Negative 394.51 times 2. Negative 789. All right, I took care of my hydrogens, took care of my carbons. Next, oxygen. Oh, which equation involves oxygen, O2? The third one does? The third one? So they all involve oxygen though, right? So I'm not really sure which one to deal with for oxygen. So I'm just going to skip it. And I'm going to skip it and let it all work out. So if you see something is in multiple equations and you don't know, thanks. If you don't know which one to take it from, we're just going to skip it for now, and we'll come back to it and make sure everything works out. Then you go on to the next substance. We need C2H5OH, and we need it as a product. We need it on the right. Which equation involves C2H5OH? The first one, right? What's wrong with the first one, though, as far as the location of C2H5OH? Yeah, it's on the opposite side. We need it as a product. So we're going to take reaction 1, and we're going to flip it. And if you flip it, that means you need to change the sign. We're going to change it to a positive sign when we write it down. And we've got the right number of them. So since it's just one of them in the equation, that's a good thing. So I'm going to actually write this side first and say 2 CO2 gas plus 2 H2O liquids and that makes C2H5OH plus 2 O2s. All right, so now I can write my delta H. This is the one I should change the sign, make it positive 875 kilojoules. Okay, now it's time to see if we did everything right. If everything worked out, then we should be able to add up these reactions, cancel things out, and when they cancel, we should end up with that target equation that's up at the top of the screen. So let's figure out what can cancel. If things are on the left side of the arrow and they're on the right side of the arrow, they can cancel. If you have 2 of something on the left and 2 of something on the right, they totally cancel. If you have 3 of something on the left and only 2 of them on the right, then 2 of them can cancel and you're left with 1 left over on that side. So they don't always have to totally cancel depending on the coefficients. All right, I don't see anything for the blue hydrogen to cancel with. Oxygens, I've got oxygens all over the place. I've got 1 oxygen in blue, 2 in purple, and then 2 in green. Well, maybe the 2 in purple and the 2 in green would cancel, and I'm still left with the one in blue, huh? Do you see anything else, any other substances that might cancel because they're on each side of the equation? H2Os, yeah. H2Os are going to cancel, aren't they? Anybody see anything else that might cancel? 2 CO2s, good. Go ahead and cancel. Just saves you some room and saves you some effort if you cancel them right there. And then we're left with everything else. So I end up with 2 hydrogens plus oxygen plus 2 carbons. And that makes the C2H5OH. And then this is my actual answer over here, the delta H for this reaction overall. How am I going to find that? You got it. Add up the blue, the purple, and the green delta H there. So I'm going to call this negative 486 kilojoules. Don't forget the rule with adding and subtracting sig figs is you go to the least exact place value. Since the ones place, the green one just goes to the ones place. That's why I take my answer there. All right, so that we just did a Hess's law problem. That's what Hess's law is all about. Hess's law itself is the addition part at the end, but to get to that point, we have to flip reactions. We have to double them. Maybe at some point you double and you flip the same reaction. So you can do that on some problems too. All right, one more for you to try. You look at number 2 down there. See if you can kind of get it started. Just take it one substance at a time. If something appears twice, then you can just skip it. And just like in this one, we skipped the oxygens, but the oxygens worked out. And they'll work out if you just skip them. things don't cancel, but they're on the same side, so they add up together, like that 2 oxygens and 3 oxygens would come together and give us 5 oxygens total on this one. And they get sometimes you'll have 3 on the right, 2 on the left, and then 2 of them would cancel, but you could end up with a net of 1 on the right as well. So sometimes these don't always totally cancel, but that leaves you with what you're supposed to be left with in the end, which is that target reaction up there. Sometimes when I'm working through here, I can get myself into trouble because I don't keep up with states of matter like I should, either saving room or just going too fast. Every once in a while, it doesn't happen often, but like H2O liquid and H2O gas would not cancel with each other. So when you're working through the problem, sometimes if you have the same substance but different states of matter, that's when you would want to pay extra close attention to it, because I've gotten myself in trouble before if I've treated all the H2Os the same, but one was a liquid and one was a gas. You have to treat them independently of each other. Does anybody think you have any questions right now? All right, so I've got some of these on Canvas that I want you to work through. Show your work on scratch paper, but you don't. Some people can do more of this in their head than I can. So I rewrite all the equations. If you can keep up with a lot of stuff in your head at the same time, you could do kind of what I'm doing at the top, or maybe I just write, oh, I need to double this one. And then maybe you would say times 2 out the side of the delta H value there. So you could keep up with them just by saying like flip and double and times 2, times -2. There are ways to kind of shorten your work a little bit if you're able to keep up with it, but at least show your delta H values that you get and how you add them all up together. I'm not sure if you can do that or not. Just do my pattern there. Just write down what you're changing so you don't have to see stuff here.